Today we're going to do a little primer on how BehaviorSpace works. BehaviorSpace is a tool that is built in the Netlogo to allow you to run experiments multiple times over and over and over again, varying things slightly between experiments and getting them out in an output. One way that you could do this is you could, if I want to investigate the influence of some scheme on how to control a dog population. So this is my street dog sim model. I can hit setup, and then I can hit go, and then I can let it run for a little while, and then when the model is done running, it spit out some output. I could then write that down if I wanted to, and then hit setup and go again, and do that a couple more 100 times, or I think I did this for thousands of times in the Netlogo, but nobody's got time for that. What we want to do is we want to use something called BehaviorSpace. So what you'll do is go to the tools file or Control-Shift-B if you're a cool person, and it pulls up this BehaviorSpace menu. And what this is, it's not going to look like this for you. It's not going to look like that for you. It is going to be empty generally here. And the way that this will work is when you look at this, these are all of the experimental runs that I've done after I've tested things over and over and over and over and over again. And then when it spits things out, what it's going to do is it's going to allow me to export these and then open them up in something like Excel or a stats program so that I can interpret those results. So what would it look like if this were empty and if I were to generate a new one? Well, we can do that later, but you can see this is how I've set up my experiment. So this is the experimental editor, and what this is doing is I can give this a name, and then it's all of the variables that I have kind of varying between things. So things like how long vaccines are going to run for, and what percentage of dogs are surviving year to year, that kind of thing. It's all built in, and these are the sliders that I'm using, or the inputs that I'm using, and then I can now set them up directly in this menu, so I don't have to tweak things in the slider and then hit setup and go again. It will automatically do all of this for me. How many repetitions is how, if I just want to see the effect of one thing, I would do one repetition. Generally, that's not very good if you're producing a model that's stochastic and variable. You'd want to run it for multiple times. You could run it for thousands of times if you really wanted to, but you could run it for, I think I ran it for 25. We don't have to worry about sequential order because it's not going to matter for really any models that we're doing. And then all of the outputs are the observable characteristics from your model, the things that you care about, and that's going to be what gets spit out in that column, right? How many dogs are there? How many vaccinations have you done? That's what's getting spit out of mine. The only real things that you need to change on the bottom right here is, do you care about what's happening on day 1 and day 2 and day 3 and day 4? Or do you really just care about what happens at the end of the run? So that's what we're using, something like this. We run metrics every step. Or do you actually use these? Do you really only care about it at the end? And if you do that, you can unclick that thing. If your model has a experimental time limit on it, so in this one, it's set up to be at 180 ticks, the model will stop. If you have a model that has code in it that will allow it to stop already, anything that tells go to stop in your model code will kind of override this. If you leave this blank, right, so if you leave this empty or as 0, what's going to do is this model is going to run forever until something in your code tells it to stop. So that's just something you've got to be a little bit careful about. So this is how I've used this in the past. What we're going to do is I'm going to have you do an experiment with virus, a code that is already in the Netlogo biology section, and we're going to edit this very briefly. I'm going to tweak it because I want to talk about how we would get it to submit or send out some data that are interesting to us. And what we can do is we're going to run some experiments in BehaviorSpace. So I'm going to add in this a global output that will tell me the highest number of individuals that are infected at any one time, what the greatest percentage of individuals is that are infected, and then it will record that and will hold on to that data. So I'm gonna pause for a second, code that real quick, and then I'm gonna show you why I'm caring about that, how I would produce that. Okay, so what I've done is I've gone into the code and I've created one global variable called max infected percentage. So I built this in, and I'm going to share this with you so you can use this. But what I'm just creating a global variable that I want to remember this thing. And then in Go, I'm going to go to my Go procedure and see how we actually do this. So this is the only new code that's in here, this only section that I've added. What this is doing is every single tick, it's going to remember what is the maximum number of people that are infected, what is the maximum percentage of people that are infected every single time. And if it's not, if it's like a time that has happened in the past, then it's not going to overwrite what that percentage is currently over that past max. It's only going to remember the high water mark. And what we're doing is, let's walk through like on the first go. Like if we'll go through the first tick in this kind of scenario. If I have 10 infected people and I have 100 total people, or I have 100 total people. So my percentage here would be 0.1, it would be, or my ratio would be here would be 0.1. So then I would say let temp max, and remember, at this point, the first time that you're running this code, something like max infected percentage is going to be equal to 0, right? Because if you just set up a global and don't tell it to be anything different, it's always going to be 0. So at this point, max infected equals 0. We'll say let temp max. So here's a temporary little variable that I'm trying to remember, and say, hey, here's the number of turtles that are currently sick. And then, because it's using I didn't set up the sick system, but this is just like with this thing being true. And then divided by the total number of turtles. So this is a ratio of sick turtles. What did I not call it? Oh, I spelled things wrong, sorry. So what this is going to do is temp max. At this point, temp max is, remember, is going to be 0.1. And then we'll say is temp max, which is 0.1 in this case, greater than max infected, which is 0 in this case. Then we'll say set max infected temp max. So set max infected, so this what this thing that we're trying to remember as, set it to be equal to what temp max is. Okay, so that's what's happening on time 1, or tick 0. What we want to do is, let's think about what happens if it's later in our model. So if I have 90 infected individuals out of the total, and my high water mark previously from the last time that we talked about, max infected equals 0.10. So that's my like maximum value that has ever happened so far. Well, in reality, 90%, so 0.9 people are sick this time. So what I would want to do is I'd say let temp max count turtles with sick divided by count turtles. So then in this case, temp max is 0.9. And if temp max is above max infected, so in this case, yes, this is true because 0.9 is bigger than 0.1, then we would say set max infected temp max. So then at the end of this, the new value from max infected is going to be 9. So it's going to remember that high water mark, and then any time that that infection rate goes down, it's never going to have to like record all of those other smaller numbers. It's only going to record the maximum. So this is how this would go about working. And I'm going to set up a BehaviorSpace experiment for you. Okay, now we've got an experiment set up, open in BehaviorSpace. So I'm going to delete this. This is not going to be on yours. You'll have to click new and set everything up. But the way that I've done it is I have brought in first, I want to make sure that I'm exporting the data that I care about. So I'm going to put max infected percentage in the measurement reporter, and I'm going to unclick the run metrics every step because I don't care. I just care about what's happening at the end. And this will run. This model actually runs forever, so I want to put in a time limit. If not, it will just keep running and running and running and running forever. So I'm just going to like artificially choose 200 because I'm just throwing a dart at a dartboard. And I want you to do an experiment. I'd like you to pick 2 of these. There's 4 things that you can vary. You can vary duration, which is like how long somebody is sick with this, how infectious it is. So like what is the likelihood that you're going to pass that infection on to another person? The number of people is the number of like agents in the model system. And what is the chance to recover from that infection is going to be 75. So like how often you're going to switch back from an infected to a recovered person. So what I'm done here is you can actually see that I have used a little bit of the, if you press the help button, it helps you with this. And the help button shows you all about how to do this behavior space, how to set it up, all of the stuff. The big things that really matter here is like how you produce an increment value. So how you could do an experiment and then measure certain numbers between, what effect that would have on things. So in this system, I have set it to be 65, and then the number in the middle is the increment, and then what would you like to stop that at? So what it's going to do is it's going to run this 10 times with an infectiousness of 65, and then it's going to run 10 times with an infectiousness of 70, and then it's going to run it 10 times with an infectiousness of 75. So it moves up by increments of 5 until it finishes and runs an experiment at 90. And then it's going to spit this out for me. So I'm going to click OK, and I'm going to click Run. I'm going to only really want things in the table, and then so what you should be doing is you should like put this somewhere on your desktop or something like this, or in your downloads folder or wherever you want this data to be put out. And it's going to run crazy fast because Netlogo's I already set one up. And then so when you click go, when you click OK, there it goes. It runs and immediately stops. So then if we actually go to open up that folder, you're going to see that it's spit out run number 1 finished this time, and it was using a setup of 65, and then it did that 10 total times at 65, and then it moved to the next number at 70, and then it moved to the next number at 75, right? So these are going to be out of order because it's going to be whatever order that experiment came in. And what I want you to do is I want you to run this experiment using an interval, using 5 different numbers. So keeping it relatively simple. So I've obviously done way more here, so this is going to go up to like 90. It's going to have lots and lots and lots of different versions of this. But what I want you to do is choose 5 numbers, and you could use the interval number if you'd like, or you can actually just type the numbers. So now that I've gotten rid of those brackets, I could say 65, 70, 75, 80, 85. So now I've given myself 5 numbers, and the reason why we would do this is if we're doing something where like I'm not really sure what the infectiousness is. If I think it's somewhere around 75, then I will run the parameter at a wider range of numbers to see if like, hey, does that really matter? We'll talk about this. This is called local sensitivity analysis. We'll talk about this later, but like, is it really going to affect things hugely if it's at 70 or if it's at 75? So that's what this point of this stuff is. So use either infectiousness or duration or number of people or chance to recover. And what I want you to do is I want you to vary this in 5 different ways, but then I want you to do it for 2 different values. And this is where you are going to look at your data and spit out a chart out of this. You can make this in Excel if you would like to, if that's your cup of tea. I prefer something called draw.io. So I think the thing I was doing was infectiousness. So what I'm doing here is I'm just going to make like myself a little graphic. And this is going to be a different infectiousness that I'm going to be testing. So I'm going to test it at 65, 70, 75, 80, and 85, right? So here's my values, and then I'm going to use something else. So I'm going to like make some other thing, whatever else other thing that I choose to vary, number of people, etc., whatever. And then I'm going to choose a couple of values to vary within that. So I'm then going to give those values here. And what I want to do is I want to look at, so if I'm using 120 people, right? If this, you don't have to do number of people, just an example. So what I'm going to do is I'm going to find my data where I use 120 people at an infectiousness of 65, and I've spit out 10 model runs. So what I want to do is I want to probably pull the average of those 10 runs, and then I'm going to have an experimental data point that I'm going to have like some X number here, right? The maximum number of people, the high point for infectiousness. And then I'm going to do that a total of 25 times. So what I'm going to do is I'm going to essentially fill these brackets out. Again, you can do this in Excel if you want. I think draw.io is a really good, useful tool to pick up because it makes nice, little, neat little diagrams like this. And I'm going to fill these data in. And then what you'll do is you'll have a nice output of like, hey, when we have a really low infectiousness and a really high number of people, well, that's going to generally not that be a big influence. It's not going to be a huge difference between a low number of people and a high number of people. But oops, when we go up to a high infectiousness, turns out the number of people really does matter. That's the way you would go about reading this chart. So the thing that I want turned in is not a Netlogo model. I would like you to send me a picture. I'd like you to send me a picture of this output with all of these numbers filled in with some value, whatever the value is for your experiment. You choose the 5 numbers, you choose the number of repetitions, you choose the values that you are changing and modifying over the time. So what I'm going to do is I'm going to have this deleted, and I'm going to send over this experiment to you so that now you can use this virus code to do a little BehaviorSpace experiment for yourself, just to show you the qualities of why you would want to do that. All right, that's enough me jabbering. I'm going to send this over to you and then ask you to vary your experiment a little bit and just play around with it. See what numbers you might pop out of this.